We've all seen the movies, right? Humanity zipping around the galaxy, building massive cities on other planets. It's a super seductive vision. But today we're doing a massive reality check. Because when you put down the sci-fi and look at the actual physics, biology, and economics of the universe, a totally different picture emerges. Outer space isn't just sitting there waiting to be conquered. It's actually hitting our biggest sci-fi dreams with a massive, invisible brick wall. So let's dive into exactly why our future in space is going to look radically different than we ever imagined.
To get why human spaceflight is kind of stuck, you have to picture this vast, endless void. Space isn't just really far away, it is structurally designed to keep biology out. We have this habit of treating our solar system like a friendly neighborhood we can just move into once we build better engines. But the space between planets, it is actively, relentlessly hostile.
Let's start with the sheer incomprehensible emptiness of it all. When we say space is a vacuum, we aren't just talking about holding your breath. We're talking about a near-perfect expanse of hydrogen and helium plasma. Try to wrap your head around this. The plasma between galaxies has a density of less than one single hydrogen atom per cubic meter. It's literally a void of electromagnetic radiation and cosmic rays.
And to put that hostility in perspective, think about the temperature. Out there in the deep void, the baseline is a freezing negative 455 degrees Fahrenheit. That's 2.7 kelvins. And this isn't just a random number. It's literally the thermodynamic echo of creation, the afterglow from the Big Bang itself. You are dealing with absolute, bone-chilling cold as the literal baseline of the universe.
But you know what's really unsettling? This extreme alien environment starts way closer than you think. Just 100 kilometers above sea level. That is it. You could drive that distance on the highway in about an hour. But if you point your car straight up, that's where our warm, oxygen-rich atmosphere functionally ends. In a matter of minutes, you go from a perfectly hospitable planet to the brutal reality of the cosmos. We actually call this 100-kilometer boundary the Kármán line. Now, the atmosphere doesn't just hit a hard brick wall. It slowly fades into near space. But this specific line is absolutely crucial. It's the globally agreed-upon threshold where aerodynamics stops working and orbital mechanics takes the wheel. Cross that line, and you've officially left the cradle.
Getting across that line took centuries of ambition. The intellectual journey is honestly wild. Scientists actually proposed that the space between Earth and the Moon was a vacuum way back in the 17th century, way before airplanes. Then, in the 20th century, we measured the distance to Andromeda, and finally grasped how huge that void really was. For mid-century high-altitude balloon flights to Yuri Gagarin's surviving Earth orbit in 1961, humanity pushed the limits inch by inch.
After those massive early milestones, the world basically had a collective realization. Okay, we need some ground rules up here. Enter the 1967 Outer Space Treaty. This is the foundation of international space law. It legally precludes any claims of national sovereignty. You can't just fly up, plant a flag, and claim a planet. Space is legally a shared frontier, open for all of humanity to explore freely.
But here's the kicker. This is exactly where our grand legal ambitions crash headfirst into our fragile biology. Because sure, we have this enshrined legal right to go anywhere in the cosmos, but our bodies, they completely disagree.
We simply aren't built for a realm of relentless cosmic rays and microgravity. The second we leave Earth's magnetic shielding, our bodies physically start to break down. We face silent, long-term degradation from electromagnetic radiation. And even with perfect radiation shields, the absolute lack of gravity triggers a massive negative cascade. Astronauts face rapid muscle atrophy and severe bone density loss. It's like the human body figures it doesn't need to fight gravity anymore, so it just starts dismantling itself.
And if the physical toll wasn't enough, we have to talk about the cold, hard math of rocket science. Launching anything into space is wildly expensive. But humans? We are incredibly needy payloads. You need massive life support systems, tons of water, breathable air, food, radiation shielding, and a way to bring all of that heavy stuff back down safely. All of that means massive weight. And in space exploration, weight literally equals money.
So, because of those horrific biological tolls and astronomical costs, human spaceflight is strictly boxed in. Historically, our footprint is incredibly small. A human being has never traveled further than low Earth orbit and the Moon. That is our entire crewed operational radius. Meanwhile, uncrewed spacecraft, the machines we build, don't care about any of those limits.
Seriously, while we're stuck close to home, our autonomous technology has already touched every single corner of our solar system. Uncrewed spacecraft have reached all of the known planets. They've touched down on Venus, orbited Jupiter, zoomed past Pluto. Machines are vastly superior explorers. They don't need oxygen, their bones don't dissolve in transit, and best of all, we don't have to buy them a return ticket.
Now, just because humans aren't physically out there doesn't mean we left our earthly drama behind. Even with UN treaties begging us to use space peacefully, earthly geopolitics are bleeding into the vacuum. Nations have actually tested anti-satellite weapons right in Earth's orbit, creating dangerous debris fields. So while our probes explore the peaceful outer planets, we're kind of militarizing the space right over our own heads.
Looking toward the deep future, it's pretty clear who the real pioneers of the cosmos are going to be. When you map out the mass energy of the observable universe, ordinary matter, the stuff that makes up stars, planets, and us, is just a tiny sliver. The vast majority is unknown dark matter and dark energy. And the ones unraveling that massive mystery? It won't be astronauts. It's going to be our deep space probes and massive orbital telescopes.
This really demands a massive paradigm shift in how we view the future. If we want to truly understand the universe and explore the farthest reaches of the unknown, we have to accept that our greatest space explorers aren't human. They are the machines we send in our place, built specifically to thrive in that brutal void. Which leaves us with one final provocative question. If our future in space belongs entirely to our technology, are we actually exploring the universe, or are we just watching it on a screen?